So today I just want to talk about the Descartes Rule. Descartes, or Descartes, some people pronounce it Rene. So one of the famous mathematicians. So born in 1596, died in 1650. He's also a French philosopher, and he's the father, the developer, or the founder of the analytic geometry, which is for pre-calc. Cartesian coordinate plane, which means that's the XY coordinate system. So Descartes' rule of the signs, so that means, well, it's finding the positive and the negative real zeros. So for the first statement, it's showing that the number of positive real zeros of p of x is either equal to the number of changes in sign in p of x, or less than that by an even whole number. And for the number of negative real zeros of p of x, it's either equal to the number of changes in sign in p of negative x, or less than that by an even whole number. So just read through the definition, is kind of broad, so here's what that means. So let's do one example. So if someone can tell me about the name of this polynomial. Indeed, this one is called the 7-degree hexanomial. So the end behavior, we can do the analysis from 5x to the power of 7. But instead of doing the end behavior, we're finding the sign changes from one term to the next term. So from the first term to the second term, any sign changes. From positive to negative, there's one sign change, so it's 1. And then negative to negative, there's no sign change. But from negative to positive, that's another sign change, so it's 2. And then positive to positive, there's no sign change, but from positive to negative, that's another sign change. So we counted 1, 2, 3 different sign changes, so that appears. So that means we do have 3 positive zeros, or 3 positive roots, or 1 positive root. Another scenario for that one, it's because that 3 minus 2, according to the definition, is saying that it's either the n number of changes for the sign, or it's less than that number by an even number. So 3 minus 2, which is what? 1 positive root. And then for the negative zeros, so here's the way to find it. So first thing that you need to do is that we need to change the sign for positive x to negative x. So we need to plug in that negative x for all the quantity, the variable. So we got 5 quantity negative x to the power of 7 minus 3 times the quantity of negative x to the power of 5, and then minus quantity of negative x to the power of 4, plus 2 times quantity of negative x squared, and then plus negative x minus 3. And then try to simplify that to the odd number power, so that means it's going to be negative again, but negative times negative, which is what? Positive. And then negative times positive is still negative. And then positive times positive, which is what? Positive. And then positive times negative, which is negative. So minus 3, just simply bring it down. And as you can see that here from negative to positive, we do have one sign change. Positive to negative, that's another sign change. Negative to positive, that's another sign change. And then positive to negative, the fourth sign change. Negative to negative, there's no sign change right there. If someone can tell me about the number of zeros that we can find here for the negative zeros, so we do have 1, 2, 3, and 4. So according to that Descartes rule, so this one could be either showing 4 negative zeros, or 2 negative zeros, or there's no zeros at all. And here's the problem that you can try to find out the positive and the negative real zeros. So for the positive real zero, there's only one sign change. And then for the negative, so you plug in that negative for all the quantity, and then you want to show that one sign change, 2 sign changes, and then 3 sign changes. So either we do have 3 negative roots or 1 negative root. And thank you for watching this video.